Should we go ahead and get going, Steve?
Yeah, so you are taking notes, right?
Yeah, I'll take notes. Although what I did last time, the last couple of times, I just went back and looked at the video to make sure I got it right. So I think as long as the recording goes well, then it's gonna be perfect. If that video doesn't work, then we're kind of messed. It's kind of a failure. But yeah, I'll take care of it.
Yeah. Okay. I guess we can get started then. So welcome everyone to another online PIM meeting. This time in Czech Republic. Ideally, we should have been there. So let's see. I'm going to navigate the slides there. Okay, so please note well. It's the usual note well. All seen it before. And this is the agenda for today. Let us know if you have any comments on the agenda. So the first item is that Mike and I will go through the working group status. So yeah, this is our current status. We have a couple of young models that are still in the RFC editor's queue. They have been there quite a while, and I'm not sure how much longer it will take. We got 2 drafts that we requested publications since last time. And then we had a DR improvement draft that was returned to the working group some months ago before the previous IETF. And it needs some more work, and there's been changes to that, some improvements, and it will be discussed today. Also, the null-register packing draft was returned to the working group requiring more work, and there's also been a revision of that and discussion today.
In both of those drafts, I will do a better job of reviewing them before we send them to Alvaro, because in both cases it probably should have been not sent to Alvaro, so that's my bad. So Alvaro will make sure that they're thoroughly vetted before we send them to you.
Yeah, in general, we also have an issue with not getting enough review in the working group. So I'm glad that we managed to, for null register packing, we actually got a few people volunteering to give it a good review, and that was great, and should try to do that more. Then we have some more drafts. We have the IGMLT proxy young model. Nothing new since last time. Assert packing, there's a new revision that will be presented today. We have the SR point-to-point multi-point policy that will be discussed today. And finally, I want to mention our work to progress IGMP version 3, MLD version 2 to Internet standard. So we've been a little slow with that, but we had some volunteers that did a great job getting a story together, and we got the results. And there's this draft that I mentioned before that has the results, so please have a look at that. We're going to start the actual work of revising these RFCs, so looking for volunteers to work on that. I asked on the mailing list, and we got a handful of people already. But yeah, if you're interested, please respond to that email or just get in touch. I'll set up a meeting in a couple of weeks where the volunteers can discuss how they want to do their work. But basically, the work is to fix any errata, remove anything that hasn't been sufficiently implemented or deployed, clarify things where there might be interoperability issues. And that's about it. Any more comments? think we can move on to the first presentation then. With this DR improvement, I'll bring up the slides here.
Yeah, just as you look at the agenda, we did make a little bit of adjustment with, typically we do working group drafts first and then individual drafts after they're done. We did make some adjustments for some personal reasons to have some individual drafts go earlier. So just note that it's not typical.
Okay, I need to reshare here. All right, Mankamana, are you ready?
Am I audible?
Yeah.
Okay. Yeah, so we can go to the next slide. So good morning, good afternoon, good evening. And so I'll be presenting on behalf of Sandy and other authors some of the modifications which we did in this draft after AD's review comment. So we can go to the next slide. So one section of this draft will be, so basically there are two drafts which I'm going to present side by side. One is this PIM DR improvement, and there is one more for backup DR election which is coming next. And both of them are, I would say that there is a problem statement which I think both of them are trying to solve almost similar problem statement, but there are different, both are different mechanisms. So I'll first cover in this what has been updated in version 10 and 11, which is after AD's review comment. So some of the section arrangement got modified, and there was, so with respect to solution, major solution has not changed. It remains as is the way it was before even got accepted in the working group and working group last call. And there were more detail added from the algorithm side itself. And there was a request to add two different sections, or rather I would say that pointing towards to one of the draft and one of the RFC. And the RFC is the DR load balancing RFC. So that got added, that how exactly it is going to work with DRLB RFC. And if there were a couple of places where content were duplicate, they have been removed. And we added some more description to make sure that those specifications are clear enough, and there were a couple of editorial changes for which we had got comment. So we can go to the next section. So election algorithm, just to kind of recall that each DR among the DR candidate, they will, so basically the election algorithm goes almost similar to the actual PIM RFC, but we have some extra hello options where you will, any router will basically announce that they do support this specification. And once DR has been elected, the DR IP address will also be sent it. Oops. Third slide. So DR IP address will also be sent in the hello option, so that even if new router comes up with higher priority, it is not going to take over. So it gives us a option for DR to be sticky, and DDR is going to be elected among the rest other candidate other than the DR, which is, we can consider it as a second best DR in the LAN, and that is not sticky. And DR and BDR options which have been received in hello is stored locally, and that is more of implementation to make sure that you can handle the case when some new router comes, or if your priority changes, you're not trying to take over as a DR. And election algorithm, which has been defined in PIM RFC 7761, has been slightly modified to adopt these some of the new steps. Next slide. And before even going to the DR election, there is a modification in Hello Exchange. So with Hello now, we are going to send a DR address option and BDR address option, and initially both of them will be set as a 0. Sorry, it is DR address option, and both of them will be set as a 0. And after default hold timer expires, DR and BDR will be elected. And one more thing to note down here, that this specification will work only if all the routers on the LAN, they do support this particular steps. If one of the router doesn't support, we are going to fall back to base PIM functionality. Yeah, next. So working with DRLB, so RFC 8775, which became standard, I think, last year. So with DR load balancing option, there are list of candidate which will be sent in the hello option. So with this specification, if those lists are supporting PIM DR improvement draft or PIM DR improvement draft, then these option has to be added in 8775. And if it doesn't support, then it will DRLB list will not advertise this particular option. And same thing for BDR is something similar to group DR, where which has been defined in 8775. So the next step for, yeah, you can go to the next. So next step for this draft will be to have more review and provide us comment, and based on that we can take it forward. So we can go to the next draft stick. Maybe people have question, comment, and vote together.
Yeah, just get into the next one.
Sure.
Yeah. All right, it's here now.
Yeah. Yeah. So the previous draft which we spoke about, though it does elect backup DR and it talks about stickiness. So there are two, I would say there is a major difference between both of these drafts. So this draft is trying to simplify if we really need an extension in PIM hello itself to elect the PIM DR. So we can go to the next slide. So this draft was presented a few IETF back. So just to recall that by default, what exactly is the problem statement? So if you see here, very simple topology. So left hand side, you consider that left hand side R8 and R9, both of them are two PIM router on the LAN, and R8 had DR priority as 91 and R9 has DR priority as a 90. So what is going to happen initially, R8 will be elected as a DR, and R8 is going to pull the traffic from the source and forward it on the shared LAN. But if there is any failure happening in the R8, so there are certain steps which are involved before the receiver can start getting the traffic. And those steps are, first R9 has to detect the failure, and then R9 has to rebuild the tree. I think so you can still be in the slide 2. I had removed all the animation because it was becoming confusing. Slide 2 only. So, so now R9 will be elected as a DR. R9 will start building tree towards source, and that is when then finally R9 is going to forward traffic to the receiver. Now this step, there is going to be some extra time taken because the total time will be first thing R9 detects the failure and then R9 starts building the tree and starts getting the traffic. But there are requirements, there are lots of customers where multicast, looking at the way network is growing and the way mindset is changing with respect to convergence. So requirement is to achieve a faster convergence. And to achieve faster convergence, there are trade-off where it is possible to have live traffic, but still achieve a so having faster convergence is a requirement compared to saving the bandwidth. So we can go to the next slide. Slide 3.
A little bit bigger stick,
Yeah.
please.
Yeah.
Maybe just, yeah.
Okay.
Thanks.
Yeah. So in this case, that is where backup DR comes into the picture, and the overall functionality of backup DR is to actually kind of build the tree parallel to your actual DR and keep all the states with respect to PIM protocol ready at R9. And as soon as you detect the failure, you start forwarding. So in this case, the overall convergence hit, what you are going to get is how fast R9 can detect this failure. And using we have BFD and many other mechanisms where R8 to R9 failure can be detected pretty fast. And that is what it is going to save the time with respect to convergence. In this draft, the mechanism which has been defined is using the fact that when we are doing DR election, basically we are running a PIM RFC algorithm which has been defined in 7761. And if I want to run, if I want to elect a backup DR, essentially it is the second best DR. So why not to run two algorithms where all the routers on the LAN, they can run, first thing they can run is DR, and they will get to know who is the DR. Second thing, they will run a backup DR, and backup DR is going to be the second best DR. And now the rest of the routers, they don't need to know whether there is a backup DR elected or backup DR not elected. So that is what mechanism this draft usage, and that there is no need to have extra hello options among the routers. So we can go to the next slide. So yes, as I think even discussed in the previous draft, lots of vendor and lots of end customers, they do want stickiness in the PIM-DR functionality. And reason for that, if there is any new router coming into the network which has better priority, it will cause a churn in the LAN side. And the reason for churn is since DR gets changed, now new DR has to build all the multicast tree and then it will start forwarding traffic to the access. And these churns may not be really needed. And the reason I can think of a couple of reasons. It could be just maybe config issue that someone accidentally configured higher DR priority. It was not the intention, but even these kind of accident may cause a lot of traffic churn. And so customer or vendors, they really want to have a stickiness feature, stickiness functionality. Yeah, we can go to the next. So as I was discussing in PIM working group, one of the things which can be done to achieve a stickiness in the PIM is, so right now if we think the DR election procedure is actually between two things, two parameters. One is your DR priority, and then second is PIM neighbor IP address. So let's consider this case that we have 4 routers on the LAN, and each router, their priority is 100, 200, 300, and 400. So when DR election happens, router 4 will get elected as a PIM DR. But as I said, if router 5 comes with priority 500, that may end up taking DR role, and it has to go through all the tree building procedure, and then 4 will start pruning its own tree and 5 will take over. So if we want to achieve stickiness, we can utilize this characteristic where DR priority is the one who is actually driving the whole DR evolution. So can we make sure no matter which router comes in the network, 4 doesn't give away its DR role. Yeah, we can go to the next slide. So to use this functionality, the simplest way was that we have to have a way where even though router 4 has been configured with priority 400, we have to make sure that the rest of the router and the LAN, they consider that nobody can have higher priority than router 4. So for that, the mechanism which I was discussing even in the working group mailing list is, let's reserve the highest DR priority, highest possible DR priority on the LAN. And if we reserve, it is something similar to, you can say, a mutex, that once 4 has been elected as a DR, so the original DR election will happen depending on what was the actual configured DR priority. Once that has been done, router 4 will get the max DR priority, and it will start advertising its priority as a max value. So, and we consider the reason for reserving that number is to make sure that no one configures that manually. Otherwise, it will end up going into the IP address selection, and IP address cannot be controlled. It can go either side, and stickiness will not be present anymore. So, so router 4 gets it will get assigned the max DR priority, and it will advertise the max DR. Now, what is the benefit of this mechanism? Now, if you see from router 1, 2, and 3 point of view, they started getting router 4 DR priority as a max. So no matter what, they are never going to take over as a DR. So now even if a router comes with priority 500, when router 5 comes into the network and it starts advertising its own DR priority as a 500, since there is a router 4 who is already advertising max value, it is never going to take. So we will maintain the stickiness feature. Now, what would happen if this router goes down? Router 4 itself goes down. As soon as router 4 goes down, we are back to exact same way where we started. So where router 1, 2, and 3 are on the LAN. Now DR priority is 100, 200, and 300. And since their their priorities are already configured, there will be DR election. And as soon as DR election happens, the router 3 will start advertising its DR priority as a max, and same thing continues. Other benefits are, let's say that out of 4 router 4 doesn't support this specification. So if router 4 doesn't support this specification, we cannot achieve stickiness. But even in that case, it is not going to break any functionality in router 1, 2, and 3. Because router 4 will get elected as a DR on the LAN. So even since it doesn't support this new specification, it will keep announcing itself as a router 400. DR priority 400. So it will be acting as a DR till someone else takes over. So nothing changes with respect to, or I would say, with respect to backward compatibility, there is no problem here. So we can go to the next. So the reason why I was in favor of reserving max DR priority, it is for the simple fact that we don't want accidentally these numbers to be open to be configured, because if I'm using, let's say that max DR possible priority is 100, and I'm using system to assign a priority 100 to whoever is the DR at that point of time. If user also assigns a priority as 100 on the LAN, what it is going to happen that since there are 2 routers who have same DR priority, we may end up having DR again based on IP address. So that will create a chart. Next. So adjusting assert matrix. So if you see here, even though DR does play a role for sending traffic on the land, but if assert comes into the picture, it will be assert winner who is going to start forwarding traffic on the land. So one of the idea here was to, okay, can we do something to make sure that whoever was DR will always be assert winner as well? And that is where this solution came into the mind, that maybe assert matrix should also be adjusted to infinite, similar to what we did for DR priority, that whoever had been elected as a DR will always be a DR assert winner as well. And do we have next slide? So I think next slide speaks about implementation of stickiness behavior. Yeah. So we do have implementation for this behavior, what I have described in last couple of slides about stickiness. And if when I did Google, maybe someone can confirm, but I think there are other vendors who also do have implementation almost in same lines, though numbers have been not reserved yet, and it is just that the same mechanism implementation does exist. And one more thing to discuss here. So initially, I think when I presented a couple of years, so
if I can
some
comment.
a few years back when, okay.
I just want to say that when we worked on Yang models, we were checking what different vendors were doing, what kind of configuration they supported, and I think there were at least 3 or 4 different vendors that supported something like this. Either, I'm not quite sure now if it was stickiness or if it was just the first part, which is the delay when you change to your actual DR priority, but at least there were 12 vendors doing something along this line.
Yeah, so I did yesterday, since I get email, I think from Juniper attaching IPR for this draft. So when I read about that IPR, it talks about basically the way stickiness is achieved is, I think, just not doing DR election anymore, or some kind of timer related. But I did when I did Google, maybe Human can confirm. I think, and I had discussed this with Human and Jeffrey both, and I think Juniper and Nokia both have almost similar implementation with respect to stickiness. So, and just to add one more thing, that initially when I had presented this, there was a comment saying that we want to make this as an informational, because it was not defining anything, or it was not reserving anything in registry. But now I think it would be up to chairs and AD and other members in the working group, that if we plan to reserve some of the DR priority towards max, so where does draft stand? Will it be still informational, or it goes to experimental, or it goes to standard? So that's all I had.
Go ahead, Lenny.
So this concept of priority and preemption, it's not unique to PIM. It seems like it's been solved in a number of other protocols, things like VRRP and RSVP with backup paths. Can we leverage some of? I mean, what has been done? I guess one thing that I think that'd be worth looking at is, in the case of VRRP and say RSVP. Was it, a protocol level stuff, or were these just vendor implementations that made that? And I think those could be good precedents, good examples to look at, how to solve this problem, whether it's worth doing it in the protocol, or it's worth, just making it informational and, leaving it up to vendors, leaving it up to implementations. But this doesn't seem unique at all to PIM. It's a pretty common thing that happens in lots of protocols.
Yes, Alvaro.
Hey, Alvaro Retana, Routing AD. So what has me very confused is the fact that we're talking about two solutions that basically do the same thing. Mankamana just made a really good argument, in my opinion, as to why the other solution is not needed, because we can do the same thing without signaling, looks like. But of course, this draft hasn't been approved, hasn't been adopted. And in general, whether it's informational or standard, doesn't matter. If the working group is going to work on several solutions or several related solutions, even for example, the load balancing draft for the DRs, it would be really nice if they were all considered. How do they interact? What happens if one is working and the other one isn't? What happens if one guy thinks he's doing this and the other guy is doing something else? Things along those lines, regardless again of the status. So what confuses me is that, again, we seem to be circling around, and there seems to be several implementations of this or something very similar to this draft. If I remember correctly, there's at least one implementation of the DR improvement draft as well. So I think we sort of need to resolve that, right? Do we want to do one solution, two solutions, et cetera? As long as we have consensus on that, and as long as we understand how they can either interact together or not, right? And that is clearly defined in the specifications, it would make it a lot clearer.
I agree, Alvaro. So initially, we only had one solution for sticky DR, which was in that other draft. But now we have basically two proposals for how to do this. So we need to see what are the pros and cons, right? And do we actually need two solutions, or should we pick the one solution that we think is best? Or are there different use cases so that one solution is best in one scenario while in other scenarios maybe the other one? So we need to look carefully, I think, at both these solutions and see what their working group would like us to do.
And it sounds like Alvaro's opinion.
Just to be clear, I'm not either advocating for one or two, right? I want the working group to decide that. And if we're going to go with more than one, we just need to make sure that we consider how they interact or not, and that if there are multiple use cases, maybe we define that in the drafts. For this use case, it's better to use solution one, and for that other use case, maybe solution two is better, right? But it seems, still the DR, for example, the DR improvement draft, still the latest version says that it should normative back to this document if the other solution is not supported. But of course, there's no way to know if I support this draft because there's no signaling, unless there's configuration assumed and a bunch of other stuff. So there needs to be more coordination. Now, as I said, my personal opinion is that Mankamana just made a really good argument for why we only need this one. But that's me.
So
I have no vote.
Yeah. So if the working group decides, that we only need one solution that covers all the use cases, then we probably want to publish only one of the documents. At least that's my feeling. But we need to have that discussion, and I wouldn't rule out at this point that we possibly could have two documents. It depends what we decide.
Yeah, because some people may want to have a solution that does have a new hello option, and maybe some don't want to do that. It seems to me that having two solutions is okay. I mean, it's something that we may want to do. But we right now only have one working group document, so we have to make that decision first whether we want to adopt this one or not. But Alvaro, it sounds like what you're saying and what you said on the list is that let's say that we do adopt this draft that we're talking about right now. You'd prefer that both this and the DR improvement progress together, like we should hold off on progressing DR improvement until this one is also to a state where it should progress. Is that correct?
That would be very nice. They're not dependent on each other, right? So I don't need one for the other one to work, right? So they don't have to progress together. It would be very nice so that when you tell me, for example, if I don't support the improvement, then do this. Then I can look to see how this works. So it'd be really nice if they were close. They don't have to be together.
Okay.
I mean, right now it's a really weird situation because we're in the DR improvement draft. We are normatively recommending the use of a non-adopted document, which in the grand scheme of things is not a bad thing. It's just that it would be just nicer if things had progressed a lot more.
Well, I agree with that. And we can't really, we shouldn't really progress any document until we decide whether we really want to have two solutions or not, or until we have carefully considered which solution we actually think is best. Or, as I said, it's possible we decide that we actually want both solutions, but at least we need to agree on that first.
Should we
Happy for more comments here, but otherwise, I think we need to have good discussion on the mailing list where we compare the two options and figure out, what are the differences, which one is doing it this way and which is the other way, which way is working best, or under which scenarios is one solution working better than the other scenario, and so on.
I'm just going to go ahead and start a quick poll just to see, because Montgomery did make the request that we poll for adoption. So why don't we do that? And then, like you said, Stig will take it to the list.
Yeah, so even if we adopt both documents, it doesn't mean that we have to publish both documents. That's something we will decide later on.
Can people see the results right now, like what I'm seeing? Like, can you guys, like right now I see 4 people.
Yeah, I see it here at least. So 5 out
Can
of
everybody see that? Okay.
Does everyone
so
know
yeah, we've
where
got-
to go look?
Yeah, right.
There's low number.
So the poll currently is 6 in favor and 2 against, so, and now 7 in favor. So we'll let this run for a little bit longer. But we do need to take it to the list, and we'll need to make it as simple as we can when we make the request on the list, and just focus specifically on this draft. And then you're right, Stig, we can progress them both, and if we decide to discontinue one, we'll do it. Or combine them.
Yes, we have 11 people now voting. That's really good. Mine too. So at least it's looked good here, but yeah, of course we have to take it to the list, and also want to hear what concerns people have, why they are voting not to adopt, and also what makes people like this and want to adopt it.
Okay, so I'm going to end it. We have 9 in favor, 2 against. Any other questions, Makamana? Or are we good? Okay, I can't hear you, but I guess we're good. You guys still there?
Yeah, I'm bringing up the next slides here. Are you there?
Yes. Stick, can you hear me?
Go ahead. Just tell me when to proceed to the next slide.
Yeah. So, yeah, thanks to Mike and Stick for taking this a little bit early in the agenda. I have some chronic back pain, so I couldn't wait a lot longer. So thank you for taking it earlier. Next slide, please. So the proposal is to kind of build on the 8059 RFC to request new joint prune attributes for a Lisp multi-site scenario. So I'll just briefly go over the problem statement and then kind of explain the motivation for requesting the new TLV, and then we can of course take questions. So the multi-site scenario for Lisp multicast has been covered in 6831, where multicast ASM, SSM, and binder modes are supported in the overlay with an IP multicast based underlay. So the key point here is that we are using IP multicast both in the overlay and in the underlay. And just for simplicity's sake, we will just take SSM in the overlay and SSM in the underlay, but without loss of generality, this should apply for all 3 modes in the overlay. But for this purpose, or just for explaining the problem statement, I will just stick to SSM in the overlay and SSM in the underlay. The key point to note here is that you have M overlay IP multicast groups spread across multiple VRFs mapped to N underlay transport multicast groups, where M is much greater than N. So the problem gets compounded for multi-site scenarios. We will discuss that particular scenario using the next slide. But this is already being covered in section 812 of 6831. Section 812 of 6831 already notes that when you have such a scenario where you have a M to N mapping where M much greater than N, you could have traffic going to undesired locations. Now, the goal of our proposal is not to optimize or rather reduce the traffic going to undesired locations, but also fix scenarios that were related to traffic hairpinning. So the proposal we have given may not completely take away the traffic being sent to unrequired locations and then getting dropped, but definitely it should avoid traffic looping scenarios that we did observe in a particular implementation with such characteristics. The focus of this proposal is predominantly focused on the border nodes. So the protocol exchanges that we suggest are predominantly between the border nodes, but then they can be between XTRs inside a Lisp site also. But for the purpose of this presentation, I will just limit my explanation to the border nodes and how the multicast tree gets formed at the border nodes and why we require this new TLV. Next slide, please. So yeah, so if you just consider a Lisp multi-site scenario that is shown in the picture, the tree rooted at XTR 1.1, the source connected to XTR 1.1, and then there are receivers, at every site. There could be receivers on the border nodes also. So the way the SSM join would flow is basically the receiver connected to, for example, XTR 3.1, the IGMP join goes to XTR31, and then the XTR31 figures out that in order to reach the source in site 1, the blue site, I have to get to border, the site border, because it's a site external prefix. Therefore, it forwards the PIM join in the overlay to the border B3 for the source, the multicast source, that is the camera in site 1. Also maps that traffic to an underlay tree rooted at border 3, because for the XTR31, it appears that the traffic originates from B3. The B3 is the ingress ITR, right? The B3 gets both the overlay join and the underlay join. The underlay tree rooted at B3, and then the overlay tree that is rooted for the camera's EID prefix and the camera group, and then figures out that the camera EID prefix is actually reachable via B1, and therefore forwards a join in the overlay to the B1 encapsulated using the Lisp. This is again specified in 6831, nothing new. And then forwards an underlay join by mapping the overlay group to an underlay group to the tree rooted at B1. So in both the steps, we have from XTR31 to B3 and from B3 to B1, we have two joins going, one in the overlay and one in the underlay. And the process repeats at B1, where B1 figures out that in order to reach the camera, I have to reach the XTR11 and forwards the overlay join to the XTR11 using the unicast Lisp encapsulation, and also joins the tree rooted at XTR11 in the underlay. So the underlay, the overlay traffic can be mapped to the underlay stream. Now, this is fine for the unidirectional traffic. Now, I have not shown here, bidirectional traffic, but one could easily imagine that if there is a source connected to XTR31 and a receiver connected to XTR11, then the same process what I just described repeats in the opposite direction. But what could happen in this process is that the same tree that is rooted at B1 for the underlay for the traffic coming from XTR11 could also be used inside the Lisp site, blue site, for the traffic that XTR11 pulls from XTR31 via B3 and B1. So I will just repeat my last point. The central tree that is rooted at B1, which B3 is part of, for the flow that is coming from XTR11 to 31, could also be used for the traffic that is flowing from XTR31 to, say, the receiver in XTR12. So therefore, the traffic hairpinning, basically whatever traffic that was sent from XTR11 to B1 to go to B3, a copy of that packet goes to XTR12, and therefore duplicate packets get received, or even traffic looping scenarios happen in the case of bidirectional traffic between two different Lisp sites exchanging bidirectional multicast traffic. Now, therefore, if you just go to the last bullet of the previous slide, the complexity or the problem arises because the previous slide, the slide 2. The complexity arises because the border nodes perform a special role in participating in 3 PIM domains, 2 in the underlay and 1 in the overlay. Now, the reason why I say 2 PIM domains in the underlay is that, sorry, Stig, you may have to come back to the diagram. The 2 in the underlay essentially is, one is the site-facing underlay PIM domain, and then one is the core-facing underlay PIM domain, and then you have the overlay PIM domain. So, in order to kind of, break this looping or, a duplicate traffic being received, the obvious solution is to use a split horizon. And that's what the TLV proposal is. But I will pause at this point of time and take any questions and then try to clarify, because I think clarifying the problem statement here probably definitely requires additional explanation. Do I take silence to
just keep going.
Okay. So, when we thought about the solution, I think one of the key tenets that we thought was, or rather one of the key proposals that we thought was, let's try to use a split horizon approach where instead of using the same tree for the intra-site traffic and the inter-site traffic, let's try to partition the address space and use different ranges, one for the site local traffic and one for the inter-site traffic, and that way we could achieve the split horizon. So the one of the ways we could achieve the split horizon is by having the downstream border, in this case, for the traffic direction B1 to B3, let B3 request to B1 when the overlay join happens. Let B3 convey or signal the overlay to underlay mapping explicitly, and thereby you can do the split horizon and kind of achieve the partitioning that you wanted to achieve. Now, of course, this comes. Am I audible? Hello.
Prasad, we lost you for a while.
Oh, okay. What was the last sentence? I can repeat.
No idea. Just go.
Okay.
About 20 seconds.
Okay. So I was just trying to explain that the downstream router can use a signaling mechanism to convey its interest by conveying the mapping that it wants to use for the overlay to underlay using a new TLV, and that's the new proposal that we are making, where B3 essentially signals to B1 for the overlay group, for the overlay group, camera group in this case, for the camera source, please use a given underlay group that B3.
Yeah.
You're
Maybe.
gone again.
Yeah, thinking maybe not everyone here knows maybe the list multicast solution, the other RFC that well, but at least the main thing is in that solution there's already PIM joints being sent in the overlay, and we have existing attribute convey information today, but what is missing is conveying this particular information about the underlay group.
Right. So the last slide, basically, or the next slide, not the last one, the fourth one. So basically, the proposal is to have a TLV that signals the overlay to underlay mapping, where the PIM join prune attribute will be enhanced to include a new underlay multicast group, very similar to what has been proposed in 8059 for the ingress replication case, where the same TLV format is used. Instead of the multicast group, it was a unicast group. Now, we did look at 8059 and check whether the existing TLV can be used for both unicast and multicast addresses, but I think the 8059 TLV, I think I'm talking about TLV type 6 specifically, the RLOC address TLV, specifically says that it has to be a unicast address. And therefore, we kind of proposed a new TLV, or rather, we're thinking of proposing a new TLV, which signals the multicast address and not the unicast address. And the last slide, Stig, please. The next steps would be to get more comments on the draft and then ask for adoption at some point of time.
Yeah, at least I feel that it's better to have a new attribute for this instead of trying to overload the existing one with a kind of slightly different meaning.
Go ahead, AC.
I have to admit, I'm sort of took a break from PIM for a number of years. Did What's the relation with the Lisp solution and the Lisp working group?
Is the question about
Is-
presenting this draft at the Lisp?
Yes, yes. Is this, and where it should be progressed? Should it be progressed, definitely be progressed here? I mean, there's an interaction here. It's sort of like, I guess it's somewhat like MVPN in a way. You know, you can kind of look at it like that. And in MVPN, Bess owns that. So if you took that same methodology, this update would be owned by, I mean, you took that same example, this would be owned by Lisp and not PIM.
Good question. Is two parts to answer to your question, right? Should this be presented at Lisp? Absolutely, yes. Probably at the next IETF, I will present this to Lisp working group, yes. But should it be progressed in Lisp or PIM? Correct me if I'm wrong, Stig or Mike, the 8059 RFC, where the previous types have been defined, have been progressed in PIM, and therefore I submitted it to PIM. Because the type that I'm proposing is very similar to the type that has already been requested for the unicast address, and that was done in PIM.
Yeah, that makes sense to me. However, I'm looking at the Lisp charter right now, and they do have a section on multicast that does say that they do support overlay multicast by means of replication, blah, blah, blah. And it may need discussion with other working groups related to multicast, including PIM. They call out PIM. So we definitely would need to coordinate with them because it sounds like they would almost want to work on it themselves, but I'm not sure. Go ahead, Alvaro.
Hey, Alvaro Tanarelli. Yes, so I think the difference between this and, say, MVPN, for example, is at least the details in the draft about what to do with everything, right? A VPN is, you know, a countless number of pages. This is a very short draft, which seems to mostly focus on requesting the new type, right? So you said, Mike, what needs to happen, right? Which is you coordinate with Lisp, make sure that Lisp wants this, and if you know, we need to add a lot more details. According to what AC said, which makes sense, then we need to just coordinate with the list chairs on what are the other details, what needs to happen, and if they want it and we can give them a type, then it's okay to progress it here if that's all the drafts are going to say. But yeah, talk to Joel and Luigi about this.
That's exactly what happened last time. The main work was done in PIM, but it was presented and discussed in a Lisp working group as well to make sure that they actually thought it was a good idea.
Sandy has a question of Prasad about, is this the extension that you just presented for the star G or SG or for both of them?
Yes, thanks for bringing it up, Mike. It is for both, Sandy. When the star G, so the TLV proposal that can be added, Stig, can you go to slide number 4, please? Yeah, so the proposed TLV, if you look at the last bullet, it can be either appended to the joint group address encoded group format or the joint source address encoded source format. So you can use it for both.
Okay, that made sense to her. So any other questions? So, Prasad, do you want us to reach out to Joel and the other Lisp chairs, or do you want to do it? What do you prefer?
Either way is fine. I don't have a preference, Mike. Yeah, it's okay if you can start it, and I'll just chime in later.
Okay, we'll probably just do that then and copy you. We've done the same thing with other working groups. So, great. Thank you. Appreciate your time.
So just a quick note, Lisp didn't meet this week, but they're going to plan an interim soon after the IETF. So since you haven't presented this there, it would be good to present it there, right, before deciding what to do with the draft.
Okay, okay, Alvaro. I think it was Alvaro. Yes, Alvaro. I'll try to see if we can get it presented at the interim.
Thanks.
Yeah, thank you, Mike and Stig again. Thanks.
You're next.
Just making sure you guys hear me.
Yeah, hear you.
All right, perfect. I got so many microphones in front of me, I don't know which one is which anymore. I just turn them all on, and one of them just picks me up. Okay, so this is an update for point-to-multipoint policy to give you guys a little bit of overview where we are with some of the drafts out there. Obviously, the replication segment was adopted by a Spring, the point-to-multipoint policy, obviously by PIM, thank you. The MVPN, EVPN extensions by BESS was adopted. We are working very hard on the PCE draft and trying to make it adopted in the PCE working group. There is a little bit of discussions back and forth on how these objects should be presented and downloaded from the PCE to the PCC. We are hoping we're going to have a resolution to that by the next IETF, and we can adopt that draft as well. So we have a way of downloading the replication segments from the PCE to the PCC. After that, the work will go into the IDR for the BGP point-to-multipoint policy. Another way, southbound direction to download these replication segments to the network, to the PCCs. And last but not least is the ping, which we are working with some folks, and we are hoping we're going to have a solid draft by next IETF, and we're going to present it here within ping. Sorry, my apologies, go ahead.
Sorry, go ahead. I'm sorry. When you're done, I'll chime in.
Okay, sure, thank you. So one last question that is still remaining. I'm not sure what was the outcome of it, was the Yang. I don't know, it's sitting in a Spring. I don't know whether we wanted to bring it into the PIM or not. I don't know.
And that's what I was going to comment on. Yeah, great. So Stig may remember this as well, and you may too. But so last summer, I think it was, we did discuss this with the Spring chairs, and they said that they wanted to keep that in Spring unless you broke this up into 2 Yang documents, one for the P2MP policy and one for replication segment. One would be here and one would be there. So that would be your choice. It would be a lot of work, but we're certainly open to consider adoption in this working group if it's just focused on the policy part.
Okay, understood. Yeah, so let me have a conversation with the co-authors, and we'll take it from there. Thank you. Next slide, please. So while you guys are reading this, I just want to do a little bit of refresh what was the replication segment was all about. So if you folks remember, a replication segment is a seat. It can be presented via any form. MPLS is one of the ways that we are presenting it today. With the MPLS, 2 replication seat could have been connected via a unicast domain, segment routing domain. And then the seat at the replication points, the job of the seat was to provide forwarding instructions for replication of the packet. That said, we did extend the replication seat into SRv6. Nothing new here. We did not reinvent the wheel. It is the current SRv6 infrastructure. All we did is we introduced a brand new function, which is the replication function. Think of it as the MPLS replication seat, which we are just putting it in the SRv6 function, and it's called the replication function within the SRv6. Again, nothing new. All the goodies that were there previously are going to be carried forward with SRv6. The replication points will be replicating the information based on that replication seat within the SRv6. 2 replication points can be connected to each other via IPv6 unicast, which is part of the SRv6, again, draft and functionality. Next slide, please. So I kind of touched base on this slide too. I tried to simplify it as much as I could. Again, the replication function that we introduced on the replication nodes, it has the forwarding information, so we can figure out the outgoing interfaces and pushing the new replication function for downstream nodes that they're going to do the same replication over and over again until we get to the leaf node. At the leaf node, based on the replication function, we can remove the encapsulation and actually look at the payload and forward it to the hosts that are connected to that leaf node. On the bud node, obviously, it does both functions. Again, when the replication segment is examined on the bud node, there is going to be a local packet that is going to be extracted for the bud node, and there could be many other outgoing interfaces based on that replication function that the packet will be replicated and forwarded out the outgoing interfaces. Next slide, please. So just a quick example here again. The node 1 here is the root node. Node number 2 is the replication point, and your leaf nodes are number 5, 6, and 7. So, I made a connection between node 5 and 7, but that connection could not be there, or it could be there, it doesn't matter, but those are the leaf nodes. So the node 1 is the one that actually pushes the SRv6 in cap on top of the payload. It will forward it to the node 2, giving the function f1, giving the function f2 at the node 2. The replication function f2 actually going to have the forwarding information that it needs to replicate the packet via 3 to 6, or forward the packet to 5 as another OIF, or a third OIF forwarding the packet to 4, which will then forward the packet and to node number 7. So node number 2 really is working as a replication point. As you can see, the examples at node number 6, there's going to be a replication function f6, which will decapsulate the SRv6 and grab the payload and forward it to the host. Same story with node number 5. There's going to be a replication function or a replication seed of f5, which will decapsulate the SRv6 and forward the payload to the host that is connected to the node number 5. And going to number 7, we can really do a traffic engineering and force the packet through a node 4, and then eventually node 4 via a function will forward that packet to node 7, which has a replication seed of f7, and it will pop the SRv6 and forward the packet to the host. So again, nothing new. We are just using the existing SRv6 functionality out there for traffic engineering, etc., etc. We are introducing a very powerful functionality here, which is a replication function, and then you can connect two replication function via unicast domain, or you can chain them together to create a tree. It is very flexible. It can do any type of forwarding unicast or multicast anywhere within the domain of SRv6. That's all I had for this presentation. Thank you. Any comments, questions? If not, thank you very much, folks. Appreciate the time.
Yeah, thank you. So as you said, the only addition is SRv6 functionality, which you've put in the appendix. Do you intend to keep it in the appendix?
Yeah, I believe so. We need to discuss that a little bit further, but yeah, that's where it is right now. Yes, and there are some updates I think within the body of the draft. I can't remember exactly, but yeah, all the updates are already within there.
Okay. And the first slide, Stig, the only thing you just update these slides because it's now a working group draft. Go up one more. Very first slide. Yeah.
Oh
it's
yeah,
not
my apologies.
Just,
yeah,
no
I keep
but
doing
just
that. I did that for beer too.
Okay.
This
It's ours
cognitive
now,
stuff is
so.
really getting into me. Sorry.
Thank you.
It's like time is just staying still for me. It's unbelievable.
Almost over, hopefully.
Yeah. Thank you.
We had assert packing now, is that right?
Start packing now. Just about to
Hello?
share it.
Hello, can you hear me now?
Yes, we can, Yusong.
Yeah, here we
Thank you. Today I will present the update of the PIM assert mass packing draft. Next slide, please. Next slide, please. Firstly, I will give a very quick review of the problem and the solution overview of this draft. And both in the network side and the host side, in the shared network, PIM assert may be happen because the multicast service becomes widely deployed, and the large number of multicast entries increase, and maybe a large number of assert message may be sent in a very short period, and that may trigger many PIM asserts in the shared networks. So it may be make the assert packet not be processed in time, or even is discussed, and it will make the delay of the traffic duplication in the network. Next slide, please. And in this draft, we have promoted two solutions. Define the two solution, and we use the PIM hello option to distinguish these to both the solution. One is the simple packing solution, and the other is a aggregating packing solution. That is make the same source or the same RP address, and it save the packet space. And there is no change to the PIM assert state machine for this solution, for both these solutions. Next slide, please. The update of this draft, there are two aspects. One is that we update the PIM assert packing format, and the format is updated to align with the RFC 8736 and the PIM non-register packing draft. And the PIM type field update is no factor with this draft solution, because we remain to use the PIM assert type for the packing assert. And the count field we updated to align the PIM non-register packing solution, because they're no necessary to define another format. Next slide, please. And the second point, we add some brief analysis for the PIM assert timer, and sorry, the previous. And there is no effect on the existed assert timer mechanism for both the STAR-G and the SG. So because the assert winner sent the assert message due to the local period time expiration, depending on the implementation of the time accuracy, maybe in the same second or in the same millisecond, etc., that the PIM STAR-G or SG will expire, which are expired at the same time, will be sent by the packing message instead of the individual message. So there is no other change in this process.
Yeah, can I comment on that? So I think this
Okay.
this looks great to me. The only thing I would point out is if you have assert timers that expire at almost the same time, right? Then you could group multiple together. The key thing is that you don't send assert too late. But it's okay if you send assert maybe a few milliseconds or a second or something earlier, right? So maybe it could be good to have some guidance on, yeah, along those lines. Once you, let's say if you have many asserts going off like this, yeah, right now, and some are about to expire in 1 second, then you could send all of them now. And after that, they would all be in sync, so you could keep sending all of them at the same time after that.
Okay. I'll consider after the meeting. Okay. Okay. Thank you for Stig. And the next step for this draft, and I will add some operations of assert packing for how to perform this assert packing in the network. And any further comments are welcomed. That's all. Thank you.
Thank you, Isang. Appreciate it.
Okay.
Late night in China.
Yeah. Thank you.
All right, I think we got no
So,
register.
should we consider a working group last call now, or should we wait for more input first?
As one of the authors. Okay, go ahead. Sorry.
Okay. I don't think it's ready for last call now.
Okay.
Okay.
Yeah. At least I would say I read through it again, and I think it's in good shape. But yeah, I'll provide a few comments myself, and hope other people can read it and comment as well.
Great. Are we ready for
Okay.
no register? Thank you, Isang.
Okay. Thank you.
you can start.
Okay. Can everybody hear me okay?
Yeah.
All right. So yeah, we had the sixth draft for PIM null register backing, and we've uploaded the seventh one. Stig, you can go to the second slide. So there were a bunch of reviews, and thank you everybody for reviewing the draft. We fixed all the editorial comments, but there seemed to be some discussions around how the downgrade scenario would work, and if the capability check is enough for the packing null register packing to work. So I'll be just discussing the capability check once, and I hope that clears up any confusions. Let's go to the third slide, Stig. So this would be the PIM register stop bit that's sent from the RP to the DR, and it would set the P bit if it's capable of handling PIM packed null registers. So at the DR will send an unpacked null register to the RP after the RST expires, and the RP can send back the register stop with this capability bit set or unset. And at the DR, when we receive the register stop, we can just check if it's capable of handling the packed null registers or not. So this is now explained better in section 7. So any questions about this? Or any comments on if there's any way to make this better as well? Okay. There were some additional questions too, which are not covered in the slides because I sent them before they came back, but they were to address Lenny's comments. So there was a question about whether PIM null register packing will treat Anycast RP with MST any different. And the response is that it will not. For both mechanisms, PIM null register packing will work only if Anycast RPs in the entire RP set supported. So that's a comment that would be clear in the latest draft. And also, I accept the comments about the usage of PIM registers and null registers being interchangeably used in the draft. So I've fixed that as well in the latest one. That hasn't been uploaded yet. That would be the 8th draft. But we will clear any ambiguity between the usage of a null register or the usage of a data register. So the packing is only for PIM null registers or PIM register stop messages. So we will make that very clear in the 8th draft. So the last slide is just to know about the next steps and if we can make a call on this because that's all. We've addressed all the other comments based on this.
Yeah, so there were some there are some comments, especially about the downgrade scenario that people had. So I don't know whether we should try to see if they are okay or if they still think they have any concerns, or we could wait for do that during working group last call. I don't know if you have any thoughts on that, Mike.
That's what I was gonna ask you about. If when the new rev is submitted and the working group is comfortable with it, it sounds like we do need to issue another working group last call. Is that correct? Or do we just say, okay, we've
at
made all the
least,
comments?
we probably should do another last call. But at least we had some review already, so so that helps us.
Right. Okay.
But I would like to at least the people that reviewed it, I would like to get them to somehow confirm, maybe as part of the last call, that they are okay with the latest revision.
Okay. And there's, as was presented, there's one more revision coming up, correct?
So,
That's
so
right.
there's a revision
Okay.
8 coming soon, right?
Yes.
Okay, thank you. So when that's done, then Stig, we should issue a working group last call. Well, maybe we should just ping everybody who's commented to make sure that everybody's cool with what's happened to that point, do a working group last call, and then you and I thoroughly review it again one more time before we send it back to Alvaro. I think that's a good plan.
Yeah, sounds good.
Okay, thank you, everyone.
Yeah, thanks. Yeah, sorry, a little slow here. I think you.
Hi everyone, can you hear me?
Yes.
So today I'm going to talk about a stateless SRP6 point to multi-point path. Next page. So first, I would like to thank you very much for AC and Jeffrey for their valuable comments during the last adoption call. So in this updated version, we addressed all the comments. So basically, the updates is that we changed the status to experimental for this draft. We added a new section. So it's about stateless SRP6 P2MP path for English node. And then we changed the name SRP6 P2MP to a name stateless SRP6 P2MP as requested by, I think, by Jeff. So Jeff requested us to change the name because the first name they already used in the other documents. And then we added a text about a split subtree for segment list of limit size. And then we added the example for IP header using a compression seed. Next page. So in order to have a P2MP path set up in the network, we should have a controller, such as typically we use people use PCE as a controller. So initially, we should have connections between PCE to all the possible ingress nodes of the network. We only need to connect controller to possible ingress node. We don't need to controller to connect to any nodes inside the domain. In addition, initially PCE as a controller will obtain the information about the network. So this is normally done through IGP or BGP. So PCE just have a passive session or peer relation to any one of the nodes in the domain, and then PCE can get all the information about the network, such as link bandwidth, link color, and node seeds, including those multicast seeds configured on the replication node. So PCE will get all those information. So after PCE will have connection, from PCE to possible ingress node, and the PCE get those network informations. So PCE as a controller can accept a request either from application or from users. So as long as the PCE receives the request from user or application, so PCE will compute the path. After PCE get a path, it will construct a segment list for that path, and then send that segment list to the ingress node. So after ingress node receive this segment list, so ingress node will set up the path and then send the status of the path to PCE. So PCE, after receiving the report from the ingress node, PCE will record the status of this path into its path database. So that's the roughly the path computation and the path setup regarding to stateless SR36 P2MP path. Next page. So as I mentioned that we changed the name. So because SR36 P2MP, as Jeffrey Zhang mentioned, that is already used by their solutions. So they have different meanings. So we changed SR P2MP in our document to stateless SR36 P2MP because in the context of our document, the P2MP path is we don't have any states per path states in the core of the network. Next page. So also we added descriptions about a split subtree. I think this is a very good suggestion from AC. So we added text regarding to. So in the case we have limit about segment list size. So in that case, we will split subtree into multiple subtrees such that for each of the subtree, they can be encoded in the segment list of a finite size. Next page. So also, we, as a request by Jeffrey Zhang suggests that we should have an example of IP header using one of our comparisons, seed comparisons. So we give an example encoding using GSRv6 compression. So this gives details how we use compressed seed to encode a P2MP tree. Next page. Yeah, I think that's all the updates in the new version of the document. So we would welcome comments, and also as a per chair request, we will continue discuss in PIN along with those active in sprints. Thank you.
And thank you. Any questions for Waymo?
Yeah, at least one question I have is really, yeah, what the relationship should be with Spring. I don't know what the Spring working group is working in space or not.
Yeah, basically, I sent a request to Liz to get comments regarding to this draft, but we're waiting for any comments from the Spring Working Group.
Okay.
It is a challenge. Spring is so busy, and they've got so many higher priority non-multicast related discussions going on that it's hard to break in. Which is partly why we're working on some of that related work here in PIM. But
so there was a lot of, yeah, sorry. was gonna say we had a lot of discussion on the mailing list about this draft. I mean, yeah, it's great to have some activity on the mailing list. It would be good to hear, yeah, to what, you know, whether people think that it addressed those the concerns they had or not. I mean, there were people in favor of adopting it, and there were people like against. It'd be interesting to see, you know, if some people have changed their minds, if they think the new version is better, or I guess it could be worse, but hopefully better.
Yeah, it's a good question. Speaking as an individual, it goes back to, since I'm on this draft, so it just kind of goes back to, you know, we already have a good solution we've adopted within PIM. You know, do we need another solution that tackles it a different way? It's kind of the age-old question. And my views are, and I've expressed these before in other working groups, is that we should be open to multiple solutions, but if they're technically sound. And so this working group just has to decide that. But regardless, we do need to get buy-in from Spring, because we got buy-in from Spring on the existing draft that we are working on in PIM.
Right. But yeah, either way, it's good to get more comments on this and keep improving the document.
Yeah.
No comments. Yeah, I think the next steps probably should be to both to ask on the mailing list for input, and also I can also try to help trigger that, and also to reach out to Spring again.
Okay, thank you. Thank you very much.
Yeah. Carry on. All right, thanks. Yeah, anything else before we close?
Thanks for everybody's time. Good meeting.
Yeah, thanks all. Let's hope we can meet in person soon. Yeah. All right.
I'll review, and then I'll send out the notes sometime, hopefully this next week.
Yeah.
See ya.
All right. Okay. Bye.
Bye, thanks.